On January 5, 2005, in a small office at Caltech in California, an astronomer sat quietly at his computer. Though tired, he remained focused, carefully examining images that his own software had rejected months earlier. They were old photographic plates, the kind that had failed the automatic screening because the software had mistaken something unusual for simple noise. Something moving so slowly that, to a computer, its motion appeared to be nothing more than an error, a false positive. But the astronomer trusted his own instincts more than the software. He had a feeling that something important had been overlooked. For the past 3 years, he had devoted himself to a systematic search of the outer reaches of the solar system. During that time, he had discovered one distant world after another, including Quaoar, Orcus, and Sedna. Yet he believed there was still something else waiting in the darkness, something enormous, something whose existence could transform humanity's understanding of the solar system. Then, on that January day, he opened a sequence of 3 images taken on October 21, 2003, and slowly clicked through them, one frame after another. There, his eyes noticed what the software had completely overlooked: a faint, lonely point of light drifting almost imperceptibly against the background stars. Its movement was so incredibly slow that it seemed as though time itself had nearly come to a standstill. In that instant, he knew this was no mistake. This was something extraordinary. The tiny dot appeared surprisingly bright, suggesting that the object was either remarkably large or reflected an exceptional amount of sunlight. More importantly, it was moving more slowly than anything they had encountered throughout their entire search. That could only mean one thing. The object was unimaginably distant, even farther away than Pluto. His very first thought was simple: I found a planet. What he could not possibly know was that the world before him would not simply add another planet to the solar system. Instead, it was about to bring an old chapter to an end. It would erase a 75-year-old identity from astronomical history. And in that quiet office, without anyone else realizing it, the beginning of a scientific conflict had already taken shape. Over the following year and a half, astronomers around the world would find themselves divided into 2 opposing camps. It would become a debate unlike any the astronomical community had experienced before. This is the story of the distant world that, true to its name, brought discord into the world of astronomy. A world no one expected, yet one that forever changed the very definition of what a planet is. A celestial body named after the Greek goddess, whose actions were said to have begun the Trojan War. This is the story of Eris, a world that not only reshaped the map of the solar system, but also divided an entire scientific community. The astronomer's name was Mike Brown, a professor at Caltech. Working alongside him were 2 trusted colleagues, Chad Trujillo and David Rabinowitz. Together, the 3 researchers had taken on one of the greatest scientific searches in modern astronomy. Night after night, they examined the outer boundaries of the solar system, methodically surveying every region beyond Neptune. Their goal was to discover trans-Neptunian objects, often called TNOs, the icy worlds that orbit through the frozen darkness alongside Pluto, and even farther beyond it. Their most valuable instrument was the 1.2-meter Samuel Oschin telescope at Palomar Observatory. Although it was an older telescope, it was exceptionally well suited for surveying enormous areas of the night sky. Each clear night, it captured vast portions of space. Later, specialized software carefully compared those images, searching for objects that had shifted position against the distant stars. The program was designed to identify moving objects, but it also had strict limits. If an object's movement was slower than 5 arcseconds, the software automatically rejected it as insignificant. Mike Brown realized that this was exactly where an important discovery could be slipping away. If a massive object existed far beyond Pluto, its motion across the sky would be so incredibly slow that the software would never recognize it. After 3 years of searching, Brown made a remarkable decision. He would personally examine every one of those rejected images with his own eyes. It was painstaking work, with little recognition attached to it. Thousands upon thousands of images had to be inspected individually. It required months of patience and determination. Yet on that January morning in 2005, while reviewing those images from October 2003, his persistence was finally rewarded. There it was again, the faint little point of light appearing in all three photographs. Brown immediately contacted Chad Trujillo and David Rabinowitz. Together, the three scientists began carefully tracking the mysterious object. For the time being, they assigned it the temporary designation 2003 UB313, a cold, technical label without personality. But privately, among themselves, they used another name. It was a nickname they had quietly saved for many years, waiting for the day they discovered something truly extraordinary. They called it Eris. The nickname came from the television character Xena, the warrior princess who became famous during the 1990s, a fearless hero known for battling legendary creatures and mythological giants. Brown and his team had made a promise long before this discovery. That special nickname would be reserved only for the first object they found that appeared larger than Pluto. Based on their first measurements, 2003 UB3113 seemed to meet that remarkable condition. The early estimates suggested that it was, indeed, larger than Pluto. This meant they had finally found what they had been searching for all along. Later, when they discovered a moon orbiting the distant world, that moon received its own nickname as well, Gabrielle, after Xena's loyal companion. In the minds of those three scientists, a hidden world was slowly taking shape, where modern science and familiar pop culture blended together in an unexpected way. Even so, Brown's team chose not to make a public announcement right away. More observations were still needed. They had to confirm the object's size, calculate its orbit with greater precision, and carefully study the newly discovered moon. That was the scientific process. Careful, patient, thorough. But that process only works when everyone involved plays by the same rules. Then, in July of 2005, everything changed. On July 27th, another research team suddenly announced the discovery of a large trans-Neptunian object that would later be named Haumea. But there was an unsettling complication. That team had viewed observation logs that Brown's group had left publicly accessible. While technically available, using those records in that way raised serious ethical questions and left Mike Brown deeply frustrated. Suddenly, waiting was no longer an option. If they delayed any longer, someone else could examine their observations and claim the discovery of 2003 UB3113 before they could. They had to act immediately. Just 2 days later, on July 29, 2005, Brown and his colleagues held a press conference announcing the discovery of two remarkable distant worlds. One was Makemake. The other was the object they privately called Eris. From that moment forward, Eris became the center of attention. Almost immediately, the scientific world was swept into an intense debate. Early calculations suggested that this newly discovered object was about 25% larger than Pluto. If that estimate was correct, then Eris was larger than Pluto. And if Pluto was considered a planet, then Eris would also have to be considered a planet. That would bring the total number of planets in our solar system to 10. But an even bigger question soon emerged. Would it end there? If one object larger than Pluto had now been found, surely others would follow. Quaoar, Orcus, Sedna, Makemake, and Haumea had already been discovered. In the years ahead, astronomers expected many more similar worlds to appear. Would every one of them become a planet? Would future generations of students eventually have to memorize the names of 50 planets? Mike Brown later reflected on the situation with a simple but powerful observation. We had only two choices, either add new planets or remove an existing one. Within that single sentence lay the heart of the entire controversy. The International Astronomical Union, known as the IAU, serves as the official international organization responsible for astronomical names and definitions. Faced with this growing debate, it became clear that a decision could no longer be postponed. In 2006, during the organization's 26th General Assembly in Prague, the question was formally presented for a vote. For the first time in human history, scientists officially asked a question that people had simply taken for granted for centuries. A question that had never before required an exact scientific definition. What is a planet? As soon as that question entered the discussion, the astronomical community found itself divided into two opposing viewpoints. One group supported what became known as the geophysical definition. They believed a planet should be defined by its own physical characteristics. If an object possessed enough gravity to pull itself into a nearly spherical shape, then it should qualify as a planet. Nothing more was required. Under that definition, Pluto, Eris, Ceres, and perhaps dozens of other distant worlds would all be considered planets. The other group argued for what became known as the dynamical definition. In their view, being round was not enough. A true planet also had to dominate the region around its orbit through the strength of its gravity. In other words, it needed to have cleared its neighborhood. Smaller nearby objects should either become gravitationally controlled by the planet or be scattered away over time. Pluto did not meet that requirement. It traveled through the Kuiper Belt, surrounded by countless other icy bodies. It had never cleared its orbital neighborhood. Eris belonged to that same population of distant objects and therefore failed the same condition. Then came the day of the vote, an event that remains controversial among planetary scientists even today. The conference itself lasted 10 days, but the official vote was scheduled for the very last day. Around 2,500 astronomers from across the world had attended the meeting. By the time the final session arrived, however, many participants had already returned home. Only 424 astronomers remained to cast their votes. That meant only a small portion of the worldwide astronomical community ultimately decided the outcome. Among those who voted, the dynamical definition received enough support to pass. The IAU officially adopted Resolution 5A, establishing a three-part definition of a planet. First, it must orbit the Sun. Second, it must have enough gravity to achieve hydrostatic equilibrium, meaning it naturally forms a nearly spherical shape. Third, and most importantly, it must have cleared the neighborhood around its orbit. Pluto failed the third requirement. With that single decision, Pluto, which had been recognized as the 9th planet since 1930, which appeared in textbooks around the world, which generations of children had learned about in school, and which had become part of countless imaginations, lost its status as a planet. A completely new category was introduced instead: dwarf planet. Both Pluto and Eris were placed into that new classification. It was an extraordinary moment in the history of astronomy, one that officially left our solar system with 8 recognized planets. Yet the consequences reached far beyond the scientific community. The decision sparked strong emotions among people everywhere, becoming a debate that extended well beyond astronomy itself. A new word even found its way into American slang dictionaries: Plutoed, a term describing someone who had been demoted in a humiliating way. The reaction spread far beyond the scientific community. 3 U.S. states officially rejected the IAU's decision. New Mexico declared an annual Pluto Planet Day, and California passed its own resolution in support of Pluto. A scientific ruling made by the International Astronomical Union had unexpectedly become part of popular culture in a way that few scientific decisions ever have. As for Mike Brown, he would forever carry a new title: the Pluto Killer. Years later, he embraced that reputation by naming his book, How I Killed Pluto and Why It Had It Coming. Yet the controversy was only beginning, because many scientists immediately pointed out weaknesses in the IAU's new definition of a planet. One concern centered on the phrase, cleared its neighborhood. Exactly how much clearing was enough? What percentage qualified? The definition offered no precise numerical standard. Another issue involved the very first requirement, that a planet must orbit the Sun. That wording applied only to our own solar system and completely ignored the thousands of known exoplanets that orbit other stars across the galaxy. Alan Stern, the principal investigator of NASA's New Horizons mission, argued that if Earth were placed at Pluto's distance from the Sun, it also would not be able to clear its neighborhood. By the IAU's own definition, Earth itself would fail to qualify as a planet. To Stern and many other planetary scientists, that revealed a fundamental problem. A scientific definition should be universal, applying equally everywhere in the universe. Instead, this one seemed designed specifically for the unique circumstances of our own solar system. Many critics believed it was not a clean scientific principle, but rather a practical compromise created in haste, one that conveniently excluded both Pluto and Eris from the list of major planets. For that reason, the debate has never truly ended. Petitions have continued to circulate. Planetary scientists have proposed alternative definitions. Even today, if you attend a planetary science conference, you will often hear researchers casually referring to Pluto and Eris as planets despite the IAU's official classification. It is a quiet disagreement that has continued for years. But while the debate carried on, the remarkable world responsible for all of this still needed an official name. Mike Brown and his team had to submit a formal proposal. And with that, another fascinating chapter of the story began. Brown's first choice was Persephone, the wife of Pluto in Greek mythology. It was a beautiful and meaningful name that naturally connected the new world with Pluto. Unfortunately, the name had already been assigned to asteroid 399 Persephone, and astronomical naming rules do not allow two objects to share the same official name. Then, there was the team's private nickname, Xena. The public loved it. In online polls, Xena ranked among the most popular suggestions, trailing only a few other candidates. But informal nicknames are not accepted as official astronomical names by the IAU. Brown briefly considered another possibility. His daughter's name was Lila, and he even maintained a page on his website with the address Planet Lila. During the growing public discussion over possible names, that web address became widely known. The name Lila was seriously considered for a time, but Brown ultimately chose not to pursue it because he did not want to create unnecessary conflict with another scientist. In the end, he selected a name that perfectly reflected everything that had happened: Eris, the Greek goddess of strife. No name could have matched the story more perfectly. According to Greek mythology, Eris was not invited to the wedding of Peleus and Thetis. Hurt by the insult, she arrived anyway and tossed a golden apple into the celebration. Inscribed on that apple were the words, "To the fairest." That single apple ignited a fierce dispute among Hera, Athena, and Aphrodite, eventually leading to the events that sparked the legendary Trojan War. A small act of resentment grew into a conflict that changed the ancient world. In much the same way, the discovery of this distant celestial body had thrown its own symbolic golden apple into astronomy. Its arrival triggered a debate that reshaped planetary science, ended Pluto's long reign as the ninth planet, and permanently changed the definition of a planet. In September 2006, the International Astronomical Union officially approved the name Eris. The moon that Mike Brown had discovered using the Keck telescope also received its official name, Dysnomia. In Greek mythology, Dysnomia was the daughter of Eris and the goddess of lawlessness. The choice carried several layers of meaning. First, it fit perfectly within Greek mythology. Second, Brown appreciated that the name echoed his wife Diane's name. And finally, there was an unexpected coincidence that delighted everyone involved. The actress who portrayed Xena on television was Lucy Lawless. The word lawless was reflected in the meaning of dysnomia, creating a playful connection that no one had originally planned. It almost felt as though the universe itself had quietly completed the story. But the greatest surprise was still waiting. 5 years later, in 2010, astronomers were presented with a rare opportunity. Eris was about to pass directly in front of a distant star in an event known as a stellar occultation. For a few brief seconds, the star's light would disappear behind Eris. By precisely measuring the timing of that disappearance from different locations across Earth, scientists could calculate Eris's true diameter with extraordinary accuracy, avoiding the distortions normally caused by Earth's atmosphere. When all the observations had been collected and the calculations were finally completed, the result astonished everyone. Eris measured 2,126 kilometers in diameter. Pluto, whose diameter was measured with remarkable precision by NASA's New Horizons spacecraft in 2015, measured 2,377 kilometers. The world once believed to be larger than Pluto was, in fact, slightly smaller. This meant that Eris was actually slightly smaller than Pluto. For nearly 5 years, the original estimates made by Mike Brown, estimates that had helped trigger one of the biggest debates in modern astronomy and ultimately led to a new definition of a planet, turned out to be just a little too high. Eris was not larger than Pluto after all. It was slightly smaller. But there was another side to the story. Although Eris was smaller in diameter, its mass was still about 27% greater than Pluto's. That meant far more material was compressed into a slightly smaller volume. In other words, Eris was significantly denser. Pluto has an average density of about 1.85 grams per cubic centimeter. Eris has a density of about 2.43 grams per cubic centimeter. That difference is remarkable, and it reveals something fascinating about the nature of these two distant worlds. Pluto is believed to be made of roughly 70% rock and 30% ice. Eris appears to be different. Most of Eris consists of rock, covered by only a relatively thin layer of ice. Beneath its brilliant frozen exterior lies a massive rocky interior. From a distance, it appears to be little more than a giant ball of ice. Yet deep below the surface rests a world dominated by stone. Its appearance hides its true nature. Even more extraordinary is the surface itself. Eris has one of the brightest surfaces anywhere in the solar system. Its albedo is approximately 0.99, meaning it reflects about 99% of the sunlight that reaches it. That value is so astonishingly high that it almost seems impossible. How can any world remain so brilliantly reflective? The answer lies in a remarkable process known as atmospheric collapse. Eris follows an extremely elongated orbit around the Sun. At its closest point, called perihelion, it comes within about 38 astronomical units of the Sun, roughly comparable to Pluto's average distance. But at its most distant point, known as aphelion, it drifts nearly 98 astronomical units away, almost 15 billion kilometers from the Sun, and roughly 3 times farther than Pluto. Completing a single journey around the Sun takes Eris 557 Earth years. More than 5.5 centuries pass before one Eris year comes to an end. As Eris slowly travels toward that distant aphelion and into unimaginable cold, something extraordinary begins to happen. Its incredibly thin atmosphere, made primarily of nitrogen and methane, starts to freeze. Little by little, the atmosphere settles onto the surface. The air itself transforms into fresh layers of brilliant frost. Imagine an entire world's atmosphere gently falling to the ground, becoming ice. Then, centuries later, as Eris slowly begins its long return toward perihelion, sunlight grows just strong enough for that frozen layer to change once again. The ice slowly turns back into gas, rebuilding the atmosphere. This remarkable cycle repeats only once every 557 years. Eris does not experience seasons the way Earth does. Instead, it experiences entire eras. One era with an atmosphere, another era where the atmosphere exists as ice covering the surface. Each phase lasts for centuries. Together, they form an endless rhythm that has continued for billions of years and will likely continue for billions more. For a very long time, scientists viewed Eris as a frozen and lifeless world, a silent sphere drifting through endless darkness, a distant shell of ice where nothing ever changed. But in 2024, observations made by the James Webb Space Telescope transformed that understanding. Webb carefully examined the methane covering Eris's surface. More importantly, it analyzed different isotopes of that methane. Some methane molecules contain ordinary hydrogen. Others contain deuterium, a heavier form of hydrogen. The ratio between deuterium and ordinary hydrogen acts like a fingerprint, revealing where the methane originally came from. If the methane had remained unchanged since the birth of the solar system, scientists would expect a much higher deuterium to hydrogen ratio. Instead, Webb measured a moderate ratio. That result suggested something remarkable. The methane is probably not simply ancient material left behind from the formation of the solar system. Instead, it appears to be generated deep within Eris itself through ongoing thermal processes. That discovery points toward heat still existing inside Eris's rocky interior, perhaps even surprisingly active heat. The study's lead scientist, Christopher Glane, described the finding with a memorable phrase: "We see interesting signs of hot times in cool places." Those words hint at an exciting possibility. Far beneath Eris's frozen crust, there may still be a hidden ocean of liquid water. An ocean kept from freezing solid by the lingering warmth of its massive rocky interior. Billions of kilometers from Earth, far beyond the warmth of the sun, surrounded by deep and almost endless darkness. And yet, perhaps, beneath that frozen shell, there exists a warm ocean. A place that, at least in theory, could provide conditions suitable for life. The world once imagined as nothing more than a frozen, silent shell may instead still be active deep within. Its rocky heart may still be beating, even after billions of years. And through all of this, Eris is not traveling through the darkness alone. It has a companion named Dysnomia. Dysnomia is the only known moon of Eris. Mike Brown and the team at the Keck Observatory discovered it in September 2005 using a telescope equipped with adaptive optics, a remarkable technology that corrects the blurring caused by Earth's atmosphere in real time. When they turned that powerful system toward Eris, a faint companion quietly appeared beside it. Dysnomia measures about 25% of Eris's diameter, small when compared with major planets, yet unusually large for the moon of a dwarf planet. It is the second largest known moon orbiting a dwarf planet, surpassed only by Charon. It is even larger than Saturn's moons Enceladus and Mimas. Yet the most fascinating thing about Dysnomia is not its size. It is its darkness. While Eris shines with one of the brightest surfaces in the entire solar system, reflecting almost all the sunlight that reaches it, Dysnomia is astonishingly dark. Its surface bears little resemblance to Eris. There is almost no sign of the brilliant ice that makes Eris appear so dazzling. Why are these two neighboring worlds so different? The leading explanation points to an ancient and violent collision. Billions of years ago, when the solar system was still young, a massive object is believed to have struck the young Eris. The tremendous impact blasted enormous amounts of material into orbit. Over time, that cloud of debris slowly gathered together, eventually forming a single moon. Dysnomia was born from that violent event. The collision likely stripped away much of the lighter frozen material, leaving behind a darker, rock-rich body. In a way, the story of Eris seems to reflect the meaning behind its own name, a world named after the goddess of strife, a daughter of chaos, a moon born from violence, forever circling a world whose discovery overturned long-held ideas about the solar system. Billions of years have passed since that ancient collision. Even now, Eris and Dysnomia continue their endless dance together along the frozen frontier of the solar system, far from the warmth of the sun, bathed only in the faintest sunlight, moving so slowly through space that time itself almost seems to stand still. Mike Brown still works at Caltech today, continuing to explore the outer solar system. Yet many people continue to know him by another name, the Pluto Killer. To some scientists, that title sounds like an insult. To others, it is a badge of honor. Brown himself sees the story very differently. During one interview, he offered a thoughtful perspective. Eris didn't kill Pluto. It revealed Pluto's true family. Perhaps those words capture the deepest truth of this remarkable story. For many decades, our mental picture of the solar system was incomplete. We imagined 8 familiar planets, followed by Pluto, a strange object that seemed different from everything else. Its orbit was far more elongated than the others. Its path was tilted, compared with the nearly flat plane followed by the major planets. Its composition of rock and ice did not neatly fit alongside either the rocky inner planets or the giant worlds of gas and ice. Pluto seemed like an unusual exception. Then Eris forced astronomers to recognize something much larger. Pluto was never an isolated oddity. It was simply the first known member of an enormous population that had remained hidden beyond Neptune. The trans-Neptunian objects, the icy inhabitants of the Kuiper Belt and the scattered disk, thousands of distant worlds, some large, some small, some following relatively stable paths, others traveling along highly elongated and chaotic orbits. Today, we understand that the solar system can be viewed as three great regions. The first consists of the rocky inner planets, stretching from Mercury to Mars. The second contains the giant planets, from Jupiter to Neptune. The third is the immense and distant realm occupied by dwarf planets and trans-Neptunian objects. Within that frozen frontier, Pluto and Eris stand among the largest and most important worlds. They are the leading members of a vast kingdom of distant icy bodies. And among them all, Eris remains one of the greatest mysteries. It is the largest known object in the solar system that no spacecraft has ever visited. NASA's New Horizons mission revealed Pluto in breathtaking detail. For the first time, humanity saw Pluto and its great moon Charon up close. But Eris remains nothing more than a tiny point of light in the darkness. Its distant landscapes are still hidden across billions of kilometers of empty space. Scientists have proposed future missions that could one day journey there. Even with today's technology, such a mission would require about 25 years to reach Eris, a voyage lasting an entire generation. Some of the scientists designing that mission today might never live to see the data return to Earth. For now, Eris continues to guard its secrets, perhaps for many years, perhaps even longer. And maybe that is the deepest lesson this distant world has to offer. The universe still holds countless mysteries waiting quietly beyond the edge of what we know. Some of them may remain hidden for generations, patiently waiting for the day when curiosity carries us a little farther into the darkness. Thank you for spending this time listening. I hope this journey through the story of Eris has given you something new to think about as you relax and drift toward sleep. Until next time, rest well, and may your night be peaceful.